Hello kids, I have an old joke for you. I may have used it before, but that's alright. What is black and white and red all over? The old answer to that one was, well, newspaper, of course. It's black and white newsprint, but now we have colored newsprint. And then the kids came along and they said, it's a skunk with diaper rash. And then another kid came along and said, no, it's not a skunk with diaper rash, but rather it's an embarrassed zebra. So, what's black and white and red all over? And I guess now black and white would be the old Kindles that they have. I think they're coming up with a color Kindle. Maybe not. Anyway, moving right along, we're now at section 11.6, which is the quadratic formula. What you learned in the last two sections was how to come up with the solutions to a quadratic equation by using a method that's known as completing the square. Now you can always complete the square to solve any equation, but you saw some of that work that we did that involved finding square roots and fractions and things, and it got really messy. So while you can always use the method of completing the square, it's much more simple and much more straightforward if you have an equation, a formula. Just a formula that you can plug values into. Well, how can we use this general form of a quadratic equation to come up with a formula? Well, what I'm going to illustrate for you is found in section 11.6 of your Algebra 1 book. And I'm going to complete the square using this general form of a quadratic equation. And you'll remember that what I've said is we want to have our variable terms on the left-hand side of the equation, and we want to have our constant term on the right-hand side of the equation. Now, you'll say, but Miss Betsy, C is a variable. Yes, the C is a variable here, but we remember that C represents a constant term. There's no X that is connected with it. Now what I just got done saying in section 11.5 is if you're going to complete the square, your leading coefficient cannot be equal to anything other than 1, which means that this leading coefficient that we have here of A can't be there, so we have to factor an A out. So A times what will give me x squared? Well, gives me ax squared, well, x squared. But there's no a here. A times what is going to give me a b over x? Well, if I have 2 times 3 halves, doesn't that give me 3? So I'm going to use that same principle here and say bx over a. What is a times bx over a? Times bx over a. We have common factors here. Factors of a. So if I have a times bx over a is equal to negative c. Now, inside the parentheses here, I have a quadratic expression with a leading coefficient of 1. So I am going to complete the square within the parentheses, bx over a, which means I'm going to add something to both sides of the equation. And what is it that I'm going to add? I'm going to figure out what I add. Well, I'm going to take half of the coefficient of the first degree term. Well, what's the coefficient of the first degree term? What's b over a times x? So b over a is the coefficient of my first degree variable term. What's half of b over a? If you take half of something, that's the same as saying that we're multiplying it by 1/2. b over a times 1/2 is b over 2a. That's what half of bx, that's half of this coefficient right here. It's b over 2a. And then I'm going to square this. What's b over 2a squared? You square the numerator and you square the denominator. B squared over 4a squared. Your eyes glazing over yet? Just hang here with me and watch what I'm doing. All I'm doing is using the methodology, using the pattern that I taught you before about how you complete the square. I take half the coefficient of that second term, half the coefficient of the first degree variable. The coefficient of the first degree variable is b over a. When I take half of that, I have b divided by 2a. In order to figure out what we add to both sides of the equation, we have to square that. b over 2a, all of that squared, we square the numerators to get b squared. We square the denominator, 2 squared, a squared. 2 squared is 4, a squared. So, I'm going to add b squared divided by 4a squared. Okay, let me rewrite that in blue. B squared divided by 4a squared. Okay, is that all that I've added? No, I've added a times b squared divided by 4a squared. Well, what is a times b squared divided by 4a squared? B squared divided by 4a squared. There's a factor of a in common here, isn't there? So all that I've actually added is b squared divided by 4a. So I need to add b squared divided by 4a. Please stop clicking, that I'm recording. I've added the same quantity to both sides of the equation. So I have x. Now, I'm going to factor this perfect square trinomial, which will give me, with inside the parentheses, I have a times the quantity x plus b over 2a. b over 2a quantity squared is equal to negative c plus b squared over 4a. How am I going to be able to combine these two? Well, I have to rewrite the negative c with the denominator of 4a. So I'm going to have minus 4ac over 4a plus b squared divided by 4a. You see where this is coming from? Well, how did I come up with this? Well, I'm going to have to multiply by 4a over 4a. We already have the negative c. Now we can combine. We have a times the quantity x plus b over 2a quantity squared, negative 4ac plus b squared, all of that over 4a. What we're doing is coming up with a theorem, coming up with a statement that's already true, that's always true. What this is actually called is we're deriving a formula. Now, we've started with the negative, and we have a square term here at the end. Usually we don't want our leading coefficient to be negative, and usually if we have a squared term, that will be the first. So what I'm going to do, I'm out of room here obviously, I'm going to rewrite this last step here as our new first step. Be very careful here not to erase anything that I have. A times x plus b over 2a, quantity squared. A times x plus b over 2a, quantity squared, is equal to, I'm going to change this order. Addition, subtraction, multiplication, they're commutative. Doesn't matter what order this is in. Addition's definitely commutative. B squared minus 4ac, all of that over 4a. And I'm thinking that that should probably be exactly what I have. Okay. A times x plus b over 2a, quantity squared, is equal to b squared minus 4ac. All of that over 4a. Now I can go ahead and erase this. What's our next step? Well, our next step is to divide by whatever my multiplier is here. Now division is the same as multiplying by the reciprocal, correct? So why don't I say 1 over a, not 1 over 9, but 1 over a times a, everyone is the same as a, times x plus b over 2a, quantity squared, is equal to 1 over a times b squared minus 4ac, all of that over 4a, and we'll close the parentheses. What have I done? I've multiplied both sides of the equation here by 1 divided by a, so the equation is still in balance. Factors of a here cancel out. Do I have anything that cancels out here? No, they can't factor that a out because these are not factors, these are terms. But now in the denominator we have a times 4 times a. So what we result in, these factors of a have canceled. We have x plus b over 2a, quantity squared, is equal to b squared minus 4ac over 4a squared. All right? Let's take a minute and look at that. Now we're going to take the square root of both sides of this equation. And this is what we'll have. We're getting very close to our formula. Take the square root. It's equal to plus or minus the square root of b squared minus 4ac divided by 4a squared. X plus b over 2a is equal to plus or minus the square root of b squared minus 4ac divided by 4a squared. Remember, when you have the square root of a rational expression or the square root of something that's in the form of a fraction, you can take the square root of the numerator, which is the square root of b squared minus 4ac, divided by the square root of the denominator. Can you take the square root of 4a squared? Sure you can. Square root of 4a squared, 2 times 2 is 4. A times a is a squared. So what you have is 2a. Now take a close look at that, and what do you notice? That's right. Look at this. We've got a common denominator there of 2a. We're going to subtract b over 2a from both sides of the equation. Minus b over 2a is equal to minus b, wrong marker, or the opposite of b divided by 2a plus or minus the square root of b squared minus 4ac, all of that over 2a. Now, we have common denominators here. X is equal to negative b, the opposite of b, plus or minus the square root of b squared minus 4ac, all of that, with my very crooked line, all of that over 2ac. Now this looks messy, but that last step, all I did was subtract b over 2a from both sides of the equation. When I subtract b over 2a from both sides of the equation, on the left side I end up with only x. On the right hand, I end up with two rational expressions, two fractions if you will. One of those is negative b over 2a. The other one is plus or minus the square root of b squared minus 4ac all over 2a. And the way that you identify like rational expressions, like algebraic rational expressions, like things that look like fractions to you, is if they have the same denominator. We have the same denominator here, which is 2a. So if the denominators are the same, you add the numerators. So you simply have negative b plus or minus the square root of b squared minus 4ac. What you have now is the formula that you were looking for. It's called the quadratic formula. And it's possible that right now what you're thinking is, I'm not so sure that that formula is any better than completing the square. This is a quadratic formula. Quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2a. Memorize the quadratic formula. You saw how I went through and used the method of completing the square to come up with this equation, and I know that you don't want to have to do that again, do you? Well, now that we have this, how are we going to use it? Let's say that we have, let me go ahead and take an example from our book. This is on page 464. Use the quadratic formula to solve x squared minus 5x minus 6. X squared minus 5x minus 6. X squared minus 5x minus 6. Well, first, what you're going to want to do is figure out what's A, and what's B, and what is C. Well, A is the coefficient of your x squared term, so A is 1. B is a negative 5, and C is a negative 6. How do I know that? Well, this formula here comes from the general form of a quadratic equation that says ax squared plus bx plus c is equal to 0. So if we're going to use the quadratic formula to solve this equation here, we have to recognize that a is 1, b is a negative 5, and c is a negative 6. And then all you have to do is plug in the values. So let's say that x is equal to the opposite of b is a negative 5, plus or minus the square root of b squared, which is negative 5 squared. Remember how I have drilled and drilled and drilled and said it over and over and over that you have to have, when you're squaring terms, that you have to put that amount that you're substituting in parentheses. It shows up really important here because negative 5 squared is very different from the opposite of 5 squared. So b squared minus 4 times a, which is 1, times c, which is a negative 6. Negative 6. All of that divided by 2 times a, which is 1. So x is equal to the opposite of negative 5, which is 5, plus or minus the square root of 25 minus a negative plus 24 divided by 2. X is equal to 5 plus or minus the square root of 49 divided by 2. Okay? What's the square root of 49? Square root of 49 is 7. So what you have now is you have x is equal to 5 plus 7 divided by 2, or x is equal to 5 minus 7 divided by 2. And I'm not liking the way that's looking right now. That's okay. X is equal to 5 plus 7 divided by 2. X is equal to 12 divided by 2. X is equal to 6. Or, like I said, x is equal to 5 minus 7 divided by 2, which is negative 2 divided by 2, which is a negative 1. So you have two possible solutions to this equation here that we arrived at by using the quadratic formula. We said that x could be either negative 1 or x could be a positive 6. When I wrote this problem up here and said let's go ahead and solve this using the quadratic formula, did any of you think, hey, why in the world would we want to use the quadratic formula for this? We can factor that. We can say x minus 6 times x plus 1 is equal to 0. Using our zero product property, we have x is equal to 6, or x is equal to minus 1. Look at that. we got the exact same problem, exact same solution by using the quadratic formula and by factoring. Now, if I would give you this problem, the x squared minus 5x minus 6 equals 0, and I said factor it, I would expect you to see that, oh, that's easy to solve just by factoring. But if for some reason you didn't pick up on that, and you went through and used the quadratic equation, and did everything correctly, you're going to get the same answer. So that's where this is going to come in very valuable for you. Not because you use it to solve simple problems like x squared minus 5x minus 6, but because you use it to solve equations that would be pretty ugly to just complete the square on. For example, let's go ahead and look at example number 2. And you'll see how nice it is to have this quadratic equation. The problem that we're solving, 3x squared plus 4x minus 8 is equal to 0. 3x squared plus 4x minus 8 is equal to 0. 3x squared plus 4x minus 8 is equal to 0. Now, the one thing that I want you to be very careful with, when you're completing the square, is this the way that we set the equation up? No, it's not. When you're completing the square, you have only the terms that contain variables on the left-hand side, and you have your constant term on the right-hand side. However, when you use the quadratic formula, you're going to have everything equal to 0. So, what's a going to be equal to? A is equal to 3, b is equal to 4, c is equal to a negative 8. Now all we have to do is substitute these values into this equation. Remember way back in September when you were first beginning to evaluate algebraic expressions, and you maybe had x squared minus yz plus 2z squared? That was a little bit difficult. Look at how far you've come. Look at what you can do. So you have x is equal to the opposite of b. The opposite of b would be the opposite of 4, plus or minus the square root of b squared, 4 squared, minus 4 times a is 3, 4 times a times c, minus 8. All of that divided by 2a, 2 times 3. X is equal to negative 4 plus or minus the square root of 16 plus, negative times negative is a positive, 12 times 8, 96. 12 times 8 is 96. Divided by 6. All right? Okay. What do I have now? X is equal to negative 4 plus or minus the square root of 112 divided by 6. And that number's pretty big. What do I know about numbers that are underneath the radical sign? You have to simplify it if it's at all possible. So I'm going to go ahead and do my work off to the right-hand side in a different color. And then as soon as I do that, I'm going to erase it. If I want to take the square root of 112, 112. Okay? Well, I know that I can't divide, but I can divide by 2. And I can divide by 4, because the last two digits put together make a 12, which is divisible by 4. So I can divide the whole thing by 4. So I have 4 times 2, 8. 4 times 8 is 32, carry 3. Okay, there's a perfect square. And this is 4 times 7. So I have 4 times 4 times 7. So the square root of 112 becomes 4 times the square root of 7. Go back and study that. If that does not make sense to you, you need to relearn, you need to review how to simplify square roots. So now we have x is equal to negative 4 plus or minus 4 times the square root of 7 divided by 6. Everyone make sure that you have this part written down on your paper, because I'm going to have to erase. Okay. If we look in this numerator, 4 and 4, we have a common factor of 4 that we can factor out. X is equal to 4 times negative 1 plus or minus the square root of 7 divided by 6. Now, why did I care about doing that? Because I knew that I was going to have a common factor of 2 here. I have a factor of 2 that I can cancel. So x is equal to 2 times negative 1 plus or minus the square root of 7 over 3. And I want to look and see what they've done. I have 2 times a negative 1 plus or minus the square root of 7, 4 and 4. I factored out 2, 2 over 3. Okay, next step. X is equal to negative 2 plus or minus 2 times the square root of 7 over 3. If you look at page 11, section 11.6, page 465, this is what your solution to this problem is. X is equal to negative 2 plus or minus 2 times the square root of 7 over 3. They wrote this as x is equal to negative 2 plus